Hello and welcome to another session in organic chemistry for class 12. Last time we had completed up to phenols. We are only left with a small little chapter, ether, ethers, which we'll be doing today, finishing today. And immediately pass on to aldehydes and ketones. Before we do so, let me ask a few self-assessment questions. Rudra, you want to ask something?
ସାର୍ ମୁଁ କହୁଥିଲି ଯେ ସାର୍ ଏଇ ସାର୍ଟା ସଲ୍ୟୁସନର ଆଉ ଗୋଟେ ଟେଷ୍ଟ କରିଥାନ୍ତି।
Solution ର
ଆଉ ଗୋଟେ ଟେଷ୍ଟ କରିଥାନ୍ତି।
solution କୋଉ solution? Liquid?
ୟେସ୍ ସାର୍ ଫାଷ୍ଟ
ଏବେ କଣ ହେଇନି? ନା ଆଉଥରେ କରିବି ବୋଲି କହିଥିଲି।
ସାର୍ ହେଇଥିଲା ଯେ ସାର୍ 20ଟା କ୍ୱେଶ୍ଚିନ୍ ହେଇଥିଲା ସାର୍ ଆଉ ଥରେ କରିବ ବୋଲି କହିଥିଲି।
ନାଇଁ ମୁଁ ଅର୍ଗାନିକର ଇଲେକ୍ଟ୍ରୋକେମିଷ୍ଟ୍ରି କାଇନେଟିକ୍ସର ନେଇଯାଇଛି ନାଇଁ?
ୟେସ୍ ସାର୍
ହେଲେ ଅର୍ଗାନିକର ରହିଛି।
ୟେସ୍ ସାର୍
ଅର୍ଗାନିକର ହାଲୋ ଆଲକେନ୍ସ ହାଲୋଆରିନ୍ସ ଏଗୁଡ଼ାକ ପ୍ଲସ୍ ଏଇ ଯୋଉ ଚାପ୍ଟର ତିନିଟା ନାଇଁ?
ୟେସ୍ ସାର୍
କରିବା. Let us proceed. Okay, we'll do that. Let us take some road map problems. Supposing we begin with propane and carry out a substitution reaction. Oh, sorry. To give a measure product A, and we go for KOH. I'm just writing for sake of uh, the popular, belief. It is aqueous KOH. But I want here to be very specific substitution product. I don't need elimination. I have made it specific. ଦେଖୁଛ? Are you writing?
यस सर, यस सर।
Satik, that's all. Oh, this is GH. This should be I. This should be I. Over.
सर आई जाए जो ई वाला सुनता कर।
If you find some, I mean, some transformation looks untenable, you bring it to mind notice, because sometimes I go out of the way. I mean, I distract while I concentrate. Sometimes I got distracted and give something wrong. So students uh, point out that. If you are very thorough, then you can detect the mistake that the teacher does by chance. I don't think there will be any rearrangement here. As I thought, the oxymercuration demercuration product will be same as the acidic hydrolysis product,
यस सर।
because there is a tertiary carbon where carbocation will be formed first. There is no room for any rearrangement. So yeah, the product would have been different had there been a secondary carbocation. Then there might have been a methyl shift or a hydride shift. Preferably, if no hydride, then methyl shift, right? Over.
यस सर।
So what is D? Oh, sorry. What is A? What is A?
सर सेकेंडरी ब्रोमाइड सर, मैंने सेकेंडरी पोजीशन में ब्रोमीन लगता
What is that?
है।
Either
टू ब्रोमो प्रोपेन।
or isopropyl bromide, isopropyl bromide, right?
यस सर।
Then it is B
सर बी हम হচ্ছে अल्कोहल जो बी आजार।
or ना तर नहीं.
सर प्रोपानॉल।
प्रोपानॉल खाली कहले तार
टू
अर्थ
प्रोपान टू प्रोपानॉल।
टू प्रोपानॉल साधारण लोक कहते प्रोपान टू ऑल नहीं
यस
आ,
सर।
आजिकल चेंज हो जाइए बहुत बहुत लोक माने बहुत टीचर माने स्टिल दे आर फॉलोइंग द ओल्ड रूल कोई बात नहीं प्रोपान टू ऑल और आइसोप्रोपाइल अल्कोहल यू मस्ट बी थोरो फॉर स्मॉल मॉलिक्यूल्स यू मस्ट बी थोरो बोथ इन UPSC as well as trivial is more powerful both for examination purpose as well as otherwise what is C
স্যার সি হচ্ছে আলডি মানে কেটন মানে অ্যাসিটন অ্যাসিটন।
because a secondary alcohol on oxidation gives a ketone. And what is this reaction called? C to D. What is this reaction called? And what is D?
তো ডি ডাবল বন্ড মানে ডাবল বন্ড ও জায়গায় CH লাগবে।
Yes. So this is CH3C and this will be a higher alkene. This is called the Wittig reaction.
ইয়েস
Remember,
স্যার। ইয়েস স্যার।
when a phosphorus halide, this is called phosphorus halide. It is prepared in a two-step reaction with ethyl bromide or ethyl halide reacting with triphenyl phosphine and then abstracting you know, mm, hydrogen ion by using a strong base phenyl lithium so that it abstracts a proton. It becomes a double bond or it is ionic. The other structure is ionic. And you go for it, we take cyclic intermediate, the rearrangement, I mean the mechanism involves a cyclic intermediate and it gives this. Once we got this alkene as a D, then here this there will be simply hydration. Because a carbocation will be formed here, electrophilic addition. So no room for any rearrangement. And also this F will be same. This gives Markovnikov alcohol without rearrangement. But here there will be no rearrangement. So you get the same product. And since it is a tertiary alcohol, what is I? What is the major product?
এলিমিনেশন প্রোডাক্ট ডাবল বন্ড।
Internal, right?
ইয়েস স্যার।
Of course, there will be another one which is minor product, but this is the major product. Undergo dehydration to give you alkene. Then what about BS3THF? This E.
তো সেম অ্যালকোহলটা সেম।
Hmm?
টার্সিয়ারি অ্যালকোহল।
ये जहाँ ये से या ऐसे ही या ये जहाँ मर्कुरेशन ऑक्सीमर्कुरेशन डीमर्कुरेशन रे
ও
जहाँ
না না স্যার সে প্রাইমারি বলবে প্রাইমারি অ্যালকোহল।
हाँ प्राइमरी हो କିଛି ତମେ ରିଭାଇଜ କରିନ ଆଉ it will be anti-Markovnikov of alcohol primary କଣ ଏଠି OH ଟା ଏଠି ଲାଗିବ ଏଠି H ଲାଗିବ ଏଠି H ଲାଗିବ ଏଠି OH ଲାଗିବ ସେଠି ଓଲଟା ହେଇଥିଲା both the cases ରେ ସମାନ ହେଇଥିଲା but ଏଠି ଓଲଟା anti-Markovnikov of alcohol ହବ so this will be correction କର this will be
ইয়েস স্যার।
3 methyl propan to all sorry butan to all this is anti-Markovnikov addition so 1 degree କଣ କହିଲଣି 1 degree କୋଉଠି ଆସିଲା
ନାଇଁ
one
ସ୍যাର।
uh, it is almost like anti-Markovnikov addition of water. Although it is not direct addition, it is taking place in two steps. First, trialkyl borane, and then it is oxidized by hydrogen peroxide. That will give you the anti-Markovnikov alcohol. And this on, since it is a secondary alcohol, what will be Z?
মানে কেটন।
Ketone. You are still not very confident. And what will happen to when a ketone reacts with a Grignard reagent. What is H?
Sir, alcohol.
Which alcohol?
Secondary.
Secondary କେମିତି ହବ? ଏଠି କ'ଣ ହାଇଡ୍ରୋଜେନ ଲାଗିଛି? କାର୍ବନ ସାଙ୍ଗରେ କ'ଣ ହାଇଡ୍ରୋଜେନ ଲାଗିଛି?
No, sir.
କ'ଣ ଆମେ କରିଥିଲେ? With formaldehyde it gives primary, with any other aldehyde it gives
Sir,
secondary,
ters.
and with a ketone it gives tertiary. ତମେ ମୋଟେ ପ୍ରାକ୍ଟିସ କରୁନ. I was really finding a difference between other students who were very, very prominent and very smart with me earlier, in earlier times when I was teaching to a large groups. C type C stage ku jaiparuno sethipai I was telling you. So this will be CS2, CS3, and this will be OH. This will be a tertiary alcohol, that is H. Still you are not confident. Ha ha ha. ଏତିକି ଥାଉ। A B C D E F G H I J K. benzoyl peroxide. BPO is benzoyl peroxide. So this involves your class 11 topic as well as class 12 phenol. Uh, ତମ ପାଖରେ ପୁରା ଏ ବହିଟା ଅଛି ଅର୍ଗାନିକର ଯୋଉ କଣ ସେଟା
ସାର୍ MS ଚୌହାନ।
MS ଚୌହାନ ସେଇଟା କରୁଛ ନା ଆଜି ଛାଡ଼ିଦେଲେଣି?
ହଁ ସାର୍ କରୁଥିଲି।
ଷ୍ଟାର୍ଟ ତମର ସବୁ ତାର ସବୁ ଅଲଗା ଅଛି ଆଇସୋମରିଜମ ଚାପ୍ଟର ଅଲଗା ଅଛି ଜିଓସି ଚାପ୍ଟର ଅଲଗା ଅଛି ନାଇଁ
ୟେସ୍
ହାଇଡ୍ରୋକାର୍ବନ
ସାର୍।
ହାଇଡ୍ରୋକାର୍ବନ୍ସ ଅଲଗା ଅଛି ତମେ କାହିଁ କିଛି ପଚାରୁନ ଏପର୍ଯ୍ୟନ୍ତ ତା ଭିତରୁ କିଛି ଡାଉଟ୍ସ ତାପରେ ପୁଣି ଅଛି ଆଲଡିହାଇଡ୍ସ ଏଣ୍ଡ କିଟୋ ଯେମିତି ତମର ଇଏରେ ଅଛି ସେମିତି ଟାଇପର ଦେଇଛି ଆଲଡିହାଇଡ୍ସ ଏଣ୍ଡ କିଟୋନ୍ସ ତାପରେ ହାଇଡ୍ରୋକାର୍ବନ୍ସ ପରେ ଆଲକୋହଲ୍ସ ଇଥର୍ସ ଫିନଲ୍ସ ଆଉ ତାପରେ କାର୍ବକ୍ସିଲିକ ଏସିଡ୍ ଡେରିଭେଟିଭ୍ସ ଆମିନ୍ସ।
ସାର୍ ଆଉ ଟିକେ ତଳକୁ।
ସେଥିରେ ଅବଶ୍ୟ ଗୋଟେ ଇଆଡୁ ସିଆଡୁ ଜିନିଷ ଦେଇଛି ବଟ୍ କିଛି ଭଲ ବି ଦେଇଛି ଇଆଡୁ ସିଆଡୁ ଯୋଉଟା ଦରକାର ହବନି something very funny means speculative there is no such data ସେ ମନ ଇଚ୍ଛା କ୍ୱେଶ୍ଚିନ୍ କରିଛନ୍ତି anyway but many very good questions are there also you have to after finishing you have to look for all the organic questions on in mains as well as in advanced all you have to solve yourself and if you fail you can ask your doubts to me ହେଲା
ସାର୍ ଆଉ ଟିକେ।
okay
ସାର୍ H ତଳକୁ ସାର୍ ଆଉ ଟିକେ ତଳ।
ତଳକୁ ଅଛି bromine carbon disulfide since there is no one today excepting you, so we can extend the class a small little, chapter ethers we can complete today. And we next time we go for aldehydes and ketones. But you have to go in the same gear and speed that we are going here in the class.
D ଛଡା ସବୁ ହେଇଗଲା।
D ଛଡା ସବୁ ହେଇଗଲା okay এটা କଣ ହବ କୁହ then tell me what will be A
ସାର୍ ଇଥାଇଲ୍ ବେଞ୍ଜିନ୍।
ethyl benzene okay then this is Friedel-Crafts reaction alkylation and here
1 chloro ethyl benzene.
it's not called 1-chloroethyl benzene rather you say 1-chloro 1-phenyl ethane right
Yes sir.
or if you say this is of course you can call 1-chloroethyl benzene yes you're correct 1 dash 2 dash so yes no harm but once there are two carbon atoms no type C group directly attached so it should be named as aliphatic not as aromatic just to have a confirmation what this guy is saying Let us have ask that software what it is saying. Where is that? Where is that? Uh, uh, have I lost that software somewhere? And this, it is not there. And yes, I got it. Yeah, you are correct. ସେ କହିଛି ବେଞ୍ଜିନ୍ ଅନୁସାରେ କରିଛି. Okay. But the moment you change it to alcohol, since it is only carbon chain, so yeah. If it is only carbon chain, that then you name after aromatics. Yes, I was wrong. But if there is a functional type C group not directly attached to the benzene ring, then it will be 1-phenyl ethanol, right? Yes. I was just missing out there, for I wanted to verify. Rudra, you understood?
Yes, sir.
Okay, this is 1-chloroethyl benzene. And then what is alcoholic KOH will give you C?
The elimination ethylene benzene.
That is vinyl benzene. Vinyl, ethylene. Ethylene
Yes.
কি হবো? Yeah. Ethylene no, ethinyl ethinyl नहीं ये कहूतलो.
Yes, sir. EN.
Or vinyl benzene. This is called styrene. Very popularly called styrene. And styrene is a good monomer for polymerization. This will be polystyrene. Understood?
Yes, sir.
So this supposing this is CH, this is supposing pH, this is polystyrene because this is a peroxide initiator which will initiate. Of course, once you initiate, there is propagation. These are free radical polymerization techniques. Polystyrene. Polystyrene PS is a transparent plastic used in many optical components, which needs transparency. Um, and what about this one?
Sir, acetic, benzoic acid.
Benzoic acid. Because once there is one hydrogen atom, it will all this will break down and it will form benzoic acid. And then what is F?
Sir, benzene.
Benzene. Decarboxylation will occur. H will be coming here. And what about G?
Sir, SO3, sulfonic acid, benzene
Benzene
sulfonic.
sulfonic acid. Correct. Then what happens when the two steps sodium hydroxide?
Al alcohol, phenol.
Don't say alcohol. Alcohol and phenols, they are hell and heaven apart.
Yes.
The acid strength is about uh, about a million times greater, and their properties are completely different. Only the acidic property, sodium, the reaction with sodium, that is common. Others are different. Okay, then coming to this one, bromine in carbon
Sir,
trisulfide.
sir, ortho and para
Yes.
bromophenol.
Yes, ortho being the major product because bromine is a bulky group. But had you taken bromine water?
Sir, bromine ଟା ଆସିଥିଲା sir bromine water ଥିଲା ତିନିଟାଙ୍କରେ bromine.
Yes, had it been bromine water, then 2,4,6 tribromophenol. What about this? Conc HNO3 and Conc H2SO4.
Sir, 2,4,6 trinitrophenol.
Otherwise called
Picric acid.
picric acid. But actually, commercially, it is prepared in a different way. First, disulfonation occurs. Phenol is sulfonated with fuming sulfuric acid 2 times, and then nitric acid, conc nitric acid is given, so that it removes all sulfonate as SO3 2 minus, and at the three positions you get nitro. That is the commercial method. But okay, one more SAQ to wind up today's program. That I will give you. Okay. Just for helping you, I'm repeating E in both the cases because the reagents are same. That's all. Over? Hmm?
सर बी सी जाएंगे मैम।
ଆଉ ହଉନି ନା କ'ଣ?
यस सर।
ଆମେ ତ ରିଭାଇଜ କରୁନ ଆଉ କ'ଣ ତମେ ସେଇ ତମକୁ ପଚାରିଥାନ୍ତି ସେଇ ଯୋଉଗୁଡାକ ଅଛି ଏନସିଆରଟି ବହିରେ ସେତିକି ପଚାରିଥାନ୍ତି ମୁଁ ଯାହା ପଢେଇଛି। ଆଣ୍ଡ ହ୍ୱାଟ ଇଜ ଏ
सर एक क्लोरोबेंजीन।
ଆଣ୍ଡ ହ୍ୱାଟ ଇଜ ବି ଆଣ୍ଡ सी?
सर अर्थो वन क्लोरो टू मिथाइल बेंजीन आउ वन क्लोरो फोर मिथाइल बेंजीन।
Yes, because chloro is a OP director. So orthochlorotoluene, I'm just saying in a colloquial, I mean in a trivial language, parachlorotoluene. So then this is the elimination followed by substitution type of sign substitution involving benzyne intermediate, where you get two products, one normal product, normal substitution product, and another the sign substitution product, that is one place displaced from the original living group. So, I'm not asking which is major and minor, that you can study, you have not studied. The only the eye effect is considered. So I'm putting methyl here, chloro here, so that benzyne will be formed here. And then when this is first elimination will occur, then when addition, I'm sorry, when elimination will occur first to give enzyme, and then addition will occur to produce two products at the two terminals of the benzyne triple bond intermediate. So you get one product will be NH2 here, normal product, say it is D, and the sign product, one place substituted product will be this. Supposing this is D, this is E. Remember this. This is elimination followed by addition type of substitution reaction. Is not,
Yes, sir.
no, it's not nucleophilic substitution. That only happens when there is a minus M, at least one or more minus M groups, minus R groups in the orthopara positions. Then that is nucleophilic. This is something different. That is addition followed by elimination. This is elimination followed by addition, the opposite. Now here, since the we write chloro here, methyl here, since triple bond, I mean benzyne will be formed here. So one of the products will be, the sign product will be here, which I will call E once again. And the normal product from the para will be where there was the living group chloro. So this E is common and this is F. Got it?
Yes, sir.
তাহলে এই সেশনরে তো halvarins and halval alkanes পড়াইଥିଲା, and that also you have not revised from the book, from your notes.
Please.
Okay. Next time try to do more work on organic, because organic is the backbone of IIT Advanced. I don't say physical chemistry is not. Physical chemistry is equally important, which many people who are good at maths can solve it, and physics. They're good at physics and maths. They can go long way for getting good answers for physical. And organic, inorganic is also important, but usually its contribution is little less, as I am inclined to believe. But yes, you will get very good questions on transition metals, which we will discuss in our transition metals, and coordination chemistry, and normal qualitative reaction, for example, the color of the precipitate and all that, and everything included. So we will today next go for ethers. Because I feel like using the slides here to save time. Now you just write down at home so that we can finish quickly, but we will solve some problems, SAQs and all that. Now the naming is very simple: alkoxyalkane. The bigger part is alkane, the smaller part is alkoxy. This is 2-ethoxypropane, or you can call it ethyl isopropyl ether. And this is tert-butyl methyl ether, or it is 2-methoxy 2-methyl propane, and this is 3-isopropoxy, or propan 2-eloxy 2-methyl pentane. Same thing, propan 2-eloxy. If you write propan 2-eloxy, you have to bring it to the second position. Isopropoxy, first position. And then this way you can do that. And aromatic ethers, can be methoxybenzene, anisole, or methyl phenyl ether, phenyl, methyl phenyl ether. This is diphenyl ether, or phenoxybenzene is popularly called diphenyl ether. And since it is not a type A group directly attached, this is all alkoxy. These are, so it will be named as aromatic. So benzene. That means 1 chloro free propan 2 eloxy benzene. This is ethoxybenzene or phenitol. Anisole, the higher one is phenitol. Ethyl phenyl ether. Now, the interesting part of preparation of ether is the bimolecular dehydration. We have already studied that when we take excess of alcohol, using excess of 1 degree alcohol, particularly 1 degree alcohol, in presence of Kong sulfuric acid or Kong phosphoric acid acting as a dehydrating agent. So at low temperature, lower, not low, lower temperature, then substitution will occur instead of elimination, because you have more free alcohol, which are not protonated. On the other hand, with limited alcohol, 1 degree alcohol, with the same dehydrating agents, alkene is produced at a higher temperature. It will not transform to ether at a lower temperature. You have to wait till higher temperature comes and elimination will occur, because all the alcohols are protonated. 2 degree, 3 degree alcohols undergoes elimination in both the conditions to form alkene as major product. 3 degree is almost alkene. 2 degree major product is alkene if you are using a 2 degree or 3 degree alcohol and dehydrating with the same Kong sulfuric acid. Then the major product will be alkene. So you just write down this. I give you 2 minutes time. General methods of preparation. You just write down. कहीं जन्मों में तेरे दर्द आजा आजा अधूरा है अपना मिलन कहीं सदियों ने कहीं जन्मों में आजा
Yes, sir.
देखो एग्जाम्पल्स लिख दियो यदि आमे आल्किन चैप्टर पढ़ीचे एलिमिनेशन रे जे एक्सेस अल्कोहल जदि नब कम सल्फ्यूरिक एसिड रे यू विल गेट द मेजर प्रोडक्ट एज ईथर लिमिटेड नेले alkene and ether ପାଇଁ SN2 mechanism habo particularly ethyl alcohol रे because ethyl carbocation is a 1 degree is not formed SN2 it involves 3 steps protonation of alcohol eta mu karibi tame mo sangre follow karibo protonation of alcohol step 2 रे bimolecular nuclear substitution habo then deprotonation SN2 habo second step रे third step रे गोटे extra habo that is deprotonation. किंतु हमें देखिबा Samidha might have some examination, school examination going on. They are in a DAV school. Some KV, DAV guys, they are so much school centric that it's very difficult for them. I visited in Bhavani Patna. I had programs for Odia medium as well as uh, Kendriya Vidyalaya, KV, which is central school, which is CBSE. Of course, relatively they are better than the Odia medium because those areas they do not have that facilities for uh, boosting of students who are little intelligent to a higher level. The delivery of teachers there must be in the level of those who are struggling for struggling to understand science. Lecture learning.
Yes, sir.
Now see, you can also copy so that I can first proton. Supposing ethyl alcohol को हमें dehydration करूचे, dehydration में हमें this is called bimolecular substitution. That is bimolecular elimination. Sorry, it's not bimolecular elimination. This is unimolecular elimination will happen in one molecule within the same molecule. We don't write unimolecular. That is simply beta elimination. Dehydration we write. That is in fact unimolecular. But here you involve two molecules. That is bimolecular substitution. Dehydration. You can call it dehydration, but actually substitution is occurring here. SN2 substitution. First it is protonated. Then because there is excess of free alcohol, that will act as a nucleophile to attack the alpha carbon, which is electrophilic center, and then water will go as a living group. Then it is protonated. Still, it is not neutral. So deprotonation will occur to produce the final ether. These are the three steps. Write down because you can write down quickly. ହେଲା
Yes, sir.
Now see, elimination 1 degree alcohol केमती ହେଇଥାନ୍ତା ଯଦି excess alcohol ନେଇ ନଥାନ୍ତେ limited alcohol ଦେଇଥିଲେ ସେଇ ଯୋଉ second ସେଇ ଯୋଉ protonated ହେଲା ପରେ ହିଟ୍ କଲେ ଏଇଠି ବିଟା ପ୍ରୋଟନ୍ ଗୋଟେ ଲସ୍ ହେଇଥାନ୍ତା ସେଠି ଆଉ excess alcohol ନାହିଁ ଯେ ସିଏ ନ୍ୟୁକ୍ଲିଓଫାଇଲ୍ ହିସାବରେ କାମ କରିବ but here water will act as a base to remove a beta proton and because heating is happening here heat ଲେଖା ଯାଇନି so E2 elimination ହେଇକରି ସେ alkene ଦେଇଥାନ୍ତା ଯଦି limited alcohol ନେଇଥାନ୍ତା କିନ୍ତୁ 2 degree 3 degree alcohol ଯାହା ହେଲେ ବି ସେମାନେ alkene ଦେବେ because they will have more number of hydrogen atoms beta hydrogen atoms 3 3 6 2 degree ହେଲେ 3 degree ହେଲେ 9 so that when you hit ଯେମିତି ହେଲେ ତ ହିଟ୍ କରିବାକୁ ପଡ଼ିବ 140 ହଉ କି 170 ହଉ. When you heat, then you know, before excess alcohol, the same excess alcohol go for entering into the sterically hindered position because it is 2 degree 3 degree, although it is protonated, but it has to approach, or you can say carbocation will be formed. There is no need to approach from the rear side. Even if carbocation is formed, then you know um, on heating, beta elimination, beta proton elimination will happen to produce isobutylene as the major product. In fact, mostly E2 elimination occurs. The protonated ether, just like 3 degree halide, we said people think that when we treat it with alcoholic KOH, people think it will be E1, but actually it is E2. 100% E2 for giving isobutylene, almost 100%. Why almost 100%? ठीक है वो aqueous नेले ठीक है, there is some room for substitution. Therefore, E2 is the, 100% mechanism in protonated 3 degree alcohols, but in 2 degree alcohol there might be some E1, some little bit E1 will be there mixed up with E2. So it had lekhidio is very important for 2D and 3D alcohol. Even if you take excess of alcohol, but still the major product will be elimination. But 1 degree by elimination of a major product, if you take limited alcohol, it can just write down limited alcohol.
Yes, sir.
Why preparation of unsymmetrical ether not suitable by dehydration method? Because you have to use uh, two alcohols. So if you take two alcohols to get unsymmetrical ether, then you get three ethers actually. One unsymmetrical and two symmetrical, ROR, R dash OR, and ROR dash. So it will be almost very poor yield of the unsymmetrical 50%, the other one will be 25, so it's difficult to remove them. You can write down later. Williamson synthesis, we have already studied in details in our haloalkanes chapter. Alkyl halide has to be 1 degree, but alcohol can be 1 degree, 2 degree, 3 degree, where you can produce sodium salt by adding sodium metal and then go for the SN2 reaction to produce ether. So 1 degree is most suitable, 2 degree, 3 degree, they will give elimination product measure. A minor product will be substitution. And I have written all this. You have also written there, just write down the number pointer to Williamson synthesis of ether, C haloalkanes, right?
Yes, sir. Yes, sir.
This we already know. This is SN2 mechanism. There is no doubt. If you take the tertiary halide, then it will produce the absolute product is elimination. But if you want a tertiary alkyl ether, then you go for making an alcohol from the tertiary alkyl group, then sodium salt, then take a 1 degree halide, then carry out Williamson synthesis. You can write down at home. You already know it. Now you also know how to prepare isopropyl ethyl ether. Supposing, what should we take? Isopropyl chloride, sodium ethoxide, or ethyl chloride and sodium isopropoxide? Which one?
The second one, ethyl chloride and sodium.
Because once you take 2 degree halide, there will be major product will be elimination. There will be some substitution product, unlike the 3 degree, which gives almost exclusively the elimination product. So that you already know, there is no need to spend time. Then the third method is preparation of phenyl ethers. Same Williamson synthesis can be used for using phenyl ethers. See, this is aliphatic ethers. This is phenyl ethers, aromatic, aliphatic, both combined. So you don't take chlorobenzene. Chlorobenzene is absolutely unsuitable for substitution reaction. एसएन रिएक्शन के लिए ये it's not possible. We already know sp2 hybrid carbon, there is a partial double bond character. It's not possible for chlorobenzene. So take alcohol, make sodium salt. Here you can take sodium hydroxide also, and then use 1 degree halide. This has to be 1 degree halide to give you the corresponding phenyl alkyl ether. This is not recommended because this substitution is not possible, is very slow in chlorobenzene. So this you can write down at home, okay? Leave some space for
Yes, sir.
question number 3. And similarly, diphenyl ether can be prepared in another way. Instead of taking, yes, same Williamson synthesis, but here we take copper as catalyst. Simply catalyst. So we take sodium phenoxide, take phenol and add sodium hydroxide, make sodium salt, and another is bromobenzene. So since undoubtedly this is difficult, so that is being helped by copper catalyst. So this substitution, bromide ion is a better leaving group, so bromobenzene is taken rather than chlorobenzene. So it gives diphenyl ether. You can write down at home, right? Leave space.
Yes,
Okay.
sir. Yes, sir.
Then properties is interesting. You must write down at home line by line. Though slightly polar, uh, when I say polar, I mean actually the dielectric constant is low. I'm not talking of the individual dipole moment. Although slightly polar, have similar boiling point as alkenes, having comparable molecular mass, but less boiling point than isomeric alcohols, as they do not exhibit H bonding. For example, N-pentane is 309.1 K, is a liquid, slightly greater than room temperature. Room temperature is 298, is little more. Ethoxyethane is almost similar, rather it is lower, 2 degree lower. So the polarity, individual polarity has no meaning because dielectric constant is low. So forces are not hydrogen bonding, they are all van der Waals, almost like London dispersion forces. Although you can call it dipole-dipole attraction since CO bond is polar, but we don't find any such evidence from boiling point is same or even lower than the similar alkane having similar molecular mass. But look to butanol is 390 because it is having some hydrogen bonding. Solubility, they similar to alcohols. Up to 3 carbon atoms, they are completely soluble in water due to H bonding with water. Water and this is ether, water. So there is hydrogen bonding. O will provide the negative pole and H is positive pole. So because of that, it is soluble. Because there is water, but in boiling there is no water. Simply the pure alcohol, pure ether you are boiling. So butan, 1-ol, ethoxyethane have similar solubility, but they have different boiling point because it shows hydrogen bonding. Ethoxyethane does not show hydrogen bonding. Chemical property is interesting. They are relatively stable compounds, do not react with base, reacts with acid but do not react with base, active metals. They do not displace any hydrogen gas. They do not react easily with oxidizing agents and reducing agents, and even with dilute acids at room temperature. You have to heat it. Hydrolysis can happen with ethers, with sulfuric acid on mild warming heating with strong acids with sulfuric acid. Strong acids, not concentrated, strong acids like sulfuric acid. So exactly the same procedure. The ether will be protonated and water will be acting as a nucleophile to remove one alcohol as the leaving group. SN2 occurs if alkyl is primary. SN1 occurs if the alkyl group is tertiary. Um, but in case of secondary alkyl group, it may be both 1 degree and 2 degree. CO cleavage occurs. See the mechanism. Hydrolysis. Now it is protonated. Water acts as a nucleophile. It prefers there will be two alcohols, but the mechanism when you write there will be two alcohols, no doubts, from unsymmetrical ether. But the preferred mechanism should be the attack to the unhindered position. So methyl is unhindered, less hindered than ethyl. So it attacks and it produces protonated methanol and ethyl alcohol as the leaving group, and deprotonation will produce methanol. So you just write down, leave space at home and write down.
Yes, sir.
Product wise, it will be same. Had you attacked at this position, then methanol would have been the leaving group, and the protonated ethyl alcohol would have been the other product, and on deprotonation, it would have given ethyl. But the most plausible mechanism is this. Yes, I had done one question in the class. Third butyl ethyl ether, when it is hydrolyzed, what should be the mechanism? Protonated. Then, since third butyl carbocation is very, very stable, then এটি SN1 হব, SN2 হবনি। সেটি কটিলা, কটিকি ইথানলটা চালিগলা লিভিং গ্রুপ, কার্বোকাটায়ন আসিলা, then water attack কলা, then protonated alcohol hela, and deprotonation will give. So only when it is the group is the two groups, both the groups are primary, then you expect SN2. If one of them is secondary or tertiary, then SN1. If it is tertiary, 100% SN1. If it is secondary, both SN1 and SN2 will be there. Can you write down at home, or you want?
Yeah. Yes, sir.
এইটা হচ্ছে important. Reaction with symmetrical ethers with conc HX, HCl, HBr, HI. This same breaking of CO bond happens. But here, if you take 1 mole, it is very tricky to predict the major product pair. There will be pair. Once one H will be joining with O to make an alcohol, X will be joining with another R to form alkyl halide. But if it is symmetrical, the product will be same. R will be same. But it is unsymmetrical, you have to very judiciously decide which one will be the major pair. There will be two pairs of products. Just write down this. Because পরীক্ষারে এইটা বেশি পড়ে। If it is symmetrical, only one pair of product will be formed. Equimolar mixture of alkyl halide and alcohol. 2 moles नहीं गले alcoholটা ମଧ୍ୟ ହେଇଯିବ କ'ଣ ଆମେ ଜାଣିଛେ HCl HBr ନେଲେ alkyl halide ହେଇଯିବ. So if you take 2 moles or excess of HX or then you get 2 moles of alkyl halide. লিখিল?
Yes, sir.
Unsymmetrical ether, এটা লিখিয়া দরকার নেই, ମୁଁ ଖାଲି କହିଦେଉଛି ଏଠି, লিখিଦେବ ଘରେ. Unsymmetrical ether যদি 1 mole ନବ, then there can be two possibilities, ATH, ATX, ATH ATX, so RX R dash OH किंबा ROH R dash X। मेजर पेयर केमी जानिबो मु तुमको कहबी जे धर आमे नेले एथिल मेथिल इथर सेतरे 1 मोल HI देले आईटा कोठी जीवो जोठी न्यूक्लियोफिलिक अटैक करिवो बेसी संभावना अछि सेठी आई जीवो because it is less hindered, this is more hindered, although both are primary, but less hindered position रे nucleophile attack करिवो। And of course the first step is protonation of the ether from the HX, and then I minus टा कोठी attack करिवो, so preferably less hindered position attack करिवो, so major pair हबो एटा। The minor pair हबो एटा, this will be iodide and this will be alcohol, but major pair, you understood?
Yes, sir.
Mechanism टा देखि देइछि, एटा जेहेतु less hindered, I minus will attack in SN2 because it is primary, so you get this as the major pair। Okay,
Yes, sir.
এটা লিখিদেল particularly এই এক্সাম্পলটা যেটা মু হাইলাইট করছি এইটা and the mechanism। But in fact তুমি যাহা চাହୁଛ লেখো।
Yes, sir. Yes, sir.
Okay, देखो ये गोटे एग्जांपल देइछि, टॉट ब्यूटिल मेथिल इथर रे जदि तमे 1 मोल HI दबो ताले कौन हबो, कोटा मेजर प्रोडक्ट हबो, कारण जेहेतु टॉट ब्यूटाइल इज अ वेरी स्टेबल कार्बोकेटायन, तेणु प्रोटोनेट हैला परे CO क्लीवेज, CO बॉन्ड रो क्लीवेज, हेटेरोलिटिक क्लीवेज एग्री गेट 3 डिग्री कार्बोकेटायन एंड सेठी आयोडाइड आयन अटैक करियो, सो I will go join into 3 डिग्री alkyl group, and of course the other one will be alcohol, एटा कर दियो। एथरे आउ कुछ you know maybe the 100% product will be this pair। 2 डिग्री रे थिबो ताले दीटा देखो पेयर हबो, 1 डिग्री रे भी दीटा को पेयर हबो, बट मेजर पेयर you can predict which is less hindered। गोटे 1 डिग्री गोटे 2 डिग्री थिले definitely there will be two products, but the major product will be one isopropyl carbocation is fairly stable, so सेठी लागिबो nucleophile and the 1 degree will be alcohol, but एथरे 100% এই গোটিଏ pair methanol and dot butyl iodide। We are going to finish this in another 5 minutes or 10 minutes. We will finish this and go for aldehydes and ketones, which is a very big chapter. And I will not, wait for anyone to leave or to continue. As long as you are there, I will be
Yes, sir.
doing that. Now see, if another mole, second mole is given, then that alcohol will also become iodide. If it is, this is a primary alcohol, then the same SN2 mechanism will give you, so there will be two iodides। But question रे किंतु गोटे मोल पड़िले पिला माने भूलभाल कर दियंती, 2 moles पड़ले तो दीटा का iodide है जीवो। But remember, if it is a anisole, then undoubtedly एटी तो substitution ही परिबो नाही, तेणु iodide टा केवल sp3 कार्बन को आसीबो एंड एटा फेनॉल हबो। एटा लिखि दियो। ଆଉ ସେକେଣ୍ଡ ମୋଲ୍ ଦେଲେ ଆଉ ସହଜରେ ଆୟୋଡୋ ବେଞ୍ଜିନ୍ ହବନି। ବେଞ୍ଜିନ୍ ଫେନଲ୍ will not undergo ये nucleophilic substitution like alkyl halides, like alcohol. Even protonate कले भी you know फेनल चैप्टर रे आमे पढ़िने with HI or HCl HBr to make it iodo chlorobromoalkane एमती आमे पढ़िने. It's not that easy to carry out substitution in phenol.
Yes, sir.
Now see, methoxy এটা তো mechanism তুমি already জানি সারলনি protonate ହେଲା ପରେ iodide will attack at the not at the sp2 but at the sp3 and it will produce this. Phenyl carbocation is unstable, so phenyl iodide won't be formed by SN1. SN2 is not favored due to steric factor. So phenyl carbocation ମୁଁ ଲେଖିଦେଲି SN2 ରେ ମଧ୍ୟ steric factor ସକାଶେ ହବନି, sp2 hybridized carbon. So এই কার্বন অক্সিজেন বন্ড ব্রেকিং তো যেমতি হলে দরকার না, সে হবনি। এটা এটা লিখিদেব পরে। হ্যাঁ,
Yes, sir.
টিকে জায়গা ছাড় দিও, টিকে লিখিদেব। হ্যাঁ, এইটা ভি সিম্পল। অ্যারোমেটিক সরি aromatic electrophilic substitution, alkoxy group is orthopara director or a lone pair अछि. ତେଣୁ if you take bromine in acetic acid, then you get major product as para. There will be some minor ortho. Friedel-Crafts alkylation acylation madhya para major product hobo because alkoxy group is a little bulky group. Nitration para major product hobo. So in all these cases you can write down. He supposing ଏଠି ଗୋଟେ ମୁଁ କରୁଛି, ତମେ ଲେଖୁଥା, ମୁଁ ଗୋଟେ example ଏଠି ଦେଇ ଦଉଛି. Supposing we take anisole and you are carrying out bromine acetic acid. ଏଠି bromine water ଦିଆଯାଏ, bromine acetic acid ନିଆଯାଏ, so that you get a mixture of orthobromo and parabromo. Parabromo is major, এটা minor. Similarly, Friedel-Crafts acylation, alkylation, para will be the. So you can do it at home. এইটা দেয়া ହେଇଛି, ଏଇଥିରେ questions alcohols, ethers and phenols. ଏଇଥିରେ ତମକୁ ମିଳିବ question, lot of questions exam side ରେ. ତମେ ଜାଣିଛ ଏଇ exam side ଟା?
Yes, sir.
ସେଇଥିରେ ଗୁଡ଼ାଏ question ତମକୁ ମିଳିବ for practice. So this finishes our program on alcohols, ethers and phenols. ତୁମେ ବହିରୁ କରି ଚାଲ MCQ and ମତେ ପଚାରି ଚାଲ doubts. Okay, bye bye.
Okay. Pranam, sir.
प्रणाम.